Unit 2 in Principles of Operating System is Process and Threads. Usually the thread in the sense single line execution, only one task being executed at a time. The multi-threading in the sense the multiple tasks are tried to execute it at the same time. So this is a diagrammatic representation of single thread and multi-thread. Single thread in the sense only one process are being executed. Here the multiple processes are tried to execute at the same time. The client send a request. The server is provided a response based on the request. If the request is achieved, in the sense the process are being executed. The benefits is responsiveness, resource sharing, economy, and scalability. Multi-core programming as a system put the pressure on programmers to challenges that include the dividing the activities, balancing, data splitting, data dependency, testing, and debugging. So these are all the advantages of multi-core programming. So this is called it as concurrency via parallelism. Concurrent in the sense concurrently the process are executed or like in a single core systems. Whereas the parallelism in the sense multiple cores are tried to execute it at the same time. Multi-core programming paradigms are divided into two categories. One is data paradigm, other one is task paradigm. The data paradigm in the sense the same data can be accessed the multiple core. The task paradigm in the sense distributing thread across the core, each thread performing a unique operations. The data is followed by the different core. So this is a data paradigm. Here they are performing a multiple task on the same data. That is a task paradigm. So the Amdahl's rule states the speed is less than or equal to 1 divided by series of port S plus 1 divided by S, 1 minus S divided by N. The threads are divided into two categories, user level thread and a kernel level thread. User level thread are being executed at the user level. Kernel level threads are executed under an operating system. So this is a diagrammatic representation. These can be executed in a user level. These are all performed in the topmost layer of an operating system. Multi-threading models are many-to-one model, one-to-one model, many-to-many model. Many-to-one model in the sense the kernel threads are only one thread, the user threads are many threads. Many threads try to access the same kernel threads at the same time is called it as many-to-one. One-to-one in the sense one user level thread interact with one kernel level at the same time. This is called it as user level and kernel level threads. Many-to-many in the sense many user level threads are trying to access the many kernel level threads at the same time. Two-level mode. Here the both user level and the kernel level threads are being executed in a bounded way. The thread libraries. Thread library provide an API for creating and managing threads. While the threads are being created and it is executed, after the target work is completed, the threads are being cancelled. The cancellation of thread which is including of the following mode, enabling and disabling mode. The enabling mode being the threads are being executed. If there is any interrupt occur in the sense, the threads move on to the cancellation state. The scheduling activities, the user level threads are being scheduled under the threading concept, the lightweight processes. After that only it is move on to the kernel thread. These are the representation of window thread data structure. So the user level thread and the kernel level thread being activated in the termination part after it is completed the entire activities. Next part is CPU scheduling. So in this CPU scheduling, which includes the following scheduling algorithm, call it as preemptive and non-preemptive scheduling. The first, through the scheduling, the CPU utilization can be increased, throughput also increased, turnaround time, waiting time, and the response time. These aspects are all are meeting out. The first scheduling algorithm is first come first service FCFS algorithm. In this algorithm, the process are being executed based on the arrival time. Which one is arrived first, that process are being executed first. After that, the remaining process are being to be executed. The second scheduling is a shortest job first scheduling. Where this can be executed based on the burst time. When a process having a lowest burst time in the sense, that process are being executed first. After that, only the remaining process get to be executed. The last method is a round robin. The round robin method is being executed based on the priority order. When the process having higher priority, that process are being executed first. After that, remaining process are being proceeded. Thank you.